Hello everyone. Let's go over the implementation of the binary tree. So we saw the node definition, class definition for binary tree node. Okay. Now a binary tree, we saw that how we can implement binary tree. Binary tree we can implement as a array of binary nodes. Okay. Now we are going to read the information. We are going to read the parent child information from the file, and then we are going to create a array of binary tree nodes, and then we are going to update the information for each of the node. We are going to update the information with the parent, with the left child node and with the right child node. Okay. So that will look like after we construct the tree. Okay, after we construct after we populate the information of left child and the right child. So a binary tree code class definition can look like this. So this is going to have a information of number of node. We're going to read that from file, and based on that we're going to declare a of uh, array of binary tree node. Okay, so initially at the step 1 we saw that for each of the node they are going to have left child pointer 0 and right child pointer 0. Okay, then we are going to read all the information of the tree from the file, and we are going to update the left link and the right link. Okay, so the first parameter, so here the first parameter is actually the parent information, and the second parameter is the id of the child node. Okay, so this is the id of the parent node, and this is the id of the left child node. So this will be the left child of this parent node. So if 2 has left child node 3, in that case we are going to use the node id 2, and as a child node we are going to use the node id of 3. Okay, so here also this is the parent node. So for this node we are going to connect this node with the as a right child. Okay, so if we have 2 has 3 and 4 like this, say 3 is the left child, 4 is the right child. So here for this function we're going to use 2 as a node, parent node, and we're going to connect 2 with the right child 4. So there we are, as an argument we are going to send the id of 4. Okay, so after that, after these two function, that is going to actually construct the tree. So each of the node now is going to have left child and right child. So after these 2 point, when we are going to connect all the node with left child and right child, so this is going to construct the our binary tree. So we can have couple of functions. Say for example is leaf node. Say we can find whether a node is a leaf node. So how we can find that? A leaf node means it doesn't have any left child or right child. Means the address of the left child, if the address of the left child is 0 and the address of the right child is 0, that means it is a leaf node. Okay, and we can write also a function to print all the leaf node. Okay, now as we said earlier, a tree has a recursive data structure. Okay, so each of the node can have the left child and right child. So each of the left child and right child also can construct a tree. So couple of function here, couple of function we can actually calculate using the recursive function. Okay, so for example finding a height of a binary tree, we can formulate this problem this problem recursively. So the idea of calculating the height of a binary tree, the idea is that the height of a internal node in a binary tree is 1 plus the maximum of the height of its child node. Okay, so for example, if we want to find the height of node 2, we have to know the height of node 4 and node 5. So if we already know the height of node 4 and 5, we can calculate the height of node 2. Okay, so same for node 4. If we know the height of 7 and 8, we can know the height of node 4. So same for node 7. If we know the height of node 9, we can know the height of node 7. Okay, now as we know that for each recursive function we have to have a base case. Okay, so base case means the solution is already known. So for example, if the node is a leaf node, we know that for leaf node height is 0. Okay, so this is the information we are going to use, and using this information we are going to calculate the height of each of the parent node. So for example, if leaf node has height 0, so node 7 is going to have height 1. Okay, now and node 8, this is a leaf node, so it will have node height 0. Now to calculate the node 4, we have to know the to calculate the height of node 4, we have to know the height of node 7 and 8. Okay, and the maximum, we are going to add 1 with the maximum value. So node 7 has the maximum height 1, so node 4 is going to have the height 1 plus 1, 2. Okay, again see that node 5 is the leaf node, so it has node height 0. So it has height 2 and it has 0, so the maximum value is 2. Okay, so to calculate the node to calculate the height of node 2, we can just add 1 with this 2. Okay, max of 2 and 0, which is 2, and plus 1 is going to be the height of node 2, which is 3. Okay, and the same way we can calculate the height of node 6 is height of node 6 is 0, as this is a leaf node. So height node 3 has height 1, node 1 has height 2. Okay, now here the max value, max height value, node 3 has the max height value 3. So for the root node, the maximum height is going to be, the root node is going to be have the height max of 2 and 3, which is 3 plus 1, 4. Okay, so you can see that we are solving this problem recursively. The base case is that we know the height of leaf node. Okay, so using the information of the base case, we are going to calculate the height of the parent node. Okay, all right, now let's see how we can solve this problem using recursive function. So given the node ID, we can calculate the node height. So how is that? If the node ID is -1, we are going to return -1. That means there is no node ID. Okay, so if the node is leaf node, this is going to return 0, and this is our base case. Okay, all right. Okay, so now for the left child, we are going to find the left child of the node. Okay, and we are going to find the right child of the node. Okay, all right, then we are going to call maximum of get node height of, so we are going to call the recursive function recursively with get node height left child ID and get node height right child ID, and they take their maximum value +1. Okay, and the height of the tree means the height of the root node. Okay, so height of the root node is the height of the tree. So height of the tree you can find, just call the get node height of node 0, means root node, is going to give you the height of the tree. Okay.